could try and think about the probability that an American adult is not widowed. And if we wanted to figure that out, we could add up all of these numbers except for the people who are widowed. So we could say there's people who are divorced, 400 plus 979 plus 613 plus 72. And we're not going to add on the widowed part because that's what we're trying to figure out. Not widowed, 2260, and then add across the top. And that would be 064, 2260, 0.91, a 91% chance that an American adult is not widowed. So again, that's doing it from the table. And of course, we also have the way to do it with the equations. So the probability of not A is 1 minus the probability of A. And maybe I'll leave that one to you to try that out, but you should get the same answer by using the formula. And I've got another example here, which is data about sexual orientation and gender identity. So I've got female and male. Apparently in this probability sample that they did, it was a nationally representative probability sample. They only let people identify as female or male, so we're not seeing non-binary people here, but they had a range of sexual orientation. So there's asexual, bisexual, gay or lesbian, heterosexual, and then other. And this was from a large, like I said, nationally representative sample. So we could use this table to figure out the probability that an American adult picked at random is gay or lesbian. We could do some probability of A and B, male and gay. We could do some not probability. So what is the probability that an American adult is not heterosexual? Again, I'm going to leave this example for when we have synchronous time together. So far, we've just been talking about one thing happening or two things happening at once. We're also going to talk about conditional probability. So conditional probability is where you have the probability of A if B. And that's the probability of A given that we know B happened. And the way that I tend to write this is probability of A and then a vertical line, B, and I pronounce that vertical line as given. Sometimes people will also say conditioned on or something like that, but I almost always say given. So probability of A given B. So let's look at my table again. I'm going to put my totals in so that I've got them. We could think about the probability that a self-employed person is separated. So what is the probability that someone is separated given that we know they are self-employed? And so to do that one, if we're just going to logic it out from the table, we're going to say, okay, we know that they are self-employed, so that means that we can stick right in this column. We don't have to think about these people at all. We can just ignore them. So we're going to use this column, and that means that for the denominator of our fraction, we're going to use this marginal total rather than the total. So let's try it out. So given that we know we're going to be in this column, we can think about how many people are separated, and it'll be 6 out of the total of 231, 0.026, so 2.6% chance. Given that we know someone is self-employed, the probability that they are separated is 2.6%. And then we could do a similar thing. What is the probability that a separated person, so that's what we already know, that they are separated, is self-employed. So given we know that they are separated, what's the probability that they are self-employed? And for that one, we're just going to think about the row for separated. So we're not going to be thinking about anything else. And that means we're going to get to use this total as the denominator of our fraction. So it's going to be out of 72. But the top of the fraction is going to be the same. So it's going to be that 6. 6 out of 72. And that should be about 0.083 or 8.3%. So we talked about this when we were thinking about categorical variables. But order matters. So the probability of A given B is not equal to the probability of B given A. And in this case, we found that 2.6% is not the same as 8.3%. So once again, we were just logicking it through, but there's also an equation way to do this. We can say that the probability of A given B is equal to the probability of A and B over the probability of B. Again, I should probably drop my totals in here. So we could think about the same questions. So the probability that a self-employed person is separated, so that's separated given that they are self-employed. And so that would be the probability of being separated and self-employed over the probability of being self-employed. So let's see, what is the probability of being separated and self-employed? Well, that's 6 out of 2260. And that thing will be over the probability of being self-employed, which is 231 out of 2260. 0.025. We get the same answer, minus a little bit of a rounding error, that we got when we thought it through from the table. And again, you could try out the other way around, the probability that a separated person is self-employed, and we could talk about it in synchronous class. But again, it should turn out the same way that it did when we logicked it through, just looking at the table.